In practice exercise 16.13 transfer form, we're going to write a method called transferFrom, and it accepts a second list and linked int list as its parameter and moves the values from our second list to our original list. You can read through the examples as well as the conditions here. Pause the video, do that. Once you're done, let's start coding this. We can assume that this class exists and we're just going to be writing our method in this class. This is our first list that we are going to be looking at. So let's make a public void transferFrom, make sure the two separate words. As our parameter, we're taking a linked int list. For consistency, I'm just going to call this one list2. This list2 we're going to be adding into list1. So let's make our list1 ListNode, and we'll do list1 is equal to this dot front, and this is just going to be grabbing the front right here. It's going to be grabbing that front and storing it in list1. Now it's going to be null for an empty list. This is important because we're going to have to check if our front is null. So if this dot front is null, then we're just going to want to add everything that's in our list2 into list1. We could do that in an if statement, and we can do that before we even create this because then there would be no point of creating it. If this dot front is equal to null, again, we're just going to say that this dot front is equal to list2, and we're storing the front value and everything after it in here. So we're going to have to do dot front because we want the data of it. So that will be taken care of. Otherwise, let's go into a while loop now. Now this while loop is going to be pretty interesting. So in our snipping tool, I just have a little example. Currently, we have it pointing to this first value right here. Now we want to run through this entire list. So you would think, okay, well, as long as current is not equal to null, we're going to be in here. Remember though, we have to add another list after it. And we're going to want this pointer to be pointing to the start of our next list and then going on from there. So we're going to want to run this as long as both our current is not null, that's a given, but also when we get to the end, our current pointer, we're going to update it to be here. We want to run this as long as our current next is not equal to null. Because once it is, we should just break out of this while loop and then add this to the end. So we're going to focus on that. Well, current.next does not equal to null, we are going to want to just update our current pointer. Now, I always use current to represent my list nodes. I'm trying this out a little bit differently to stay consistent with our example. So let's change this from current to list1.next. And then we're going to say list1 is equal to list1.next. And that is just going to move our pointer down. That's all that's going to do till it reaches the end. Once it reaches the end, once it's at the null for the next value, but still pointing at the last value in our list1, that is when we can append our next list, or our second list, our list2. So we're going to say list1.next. So that's the next value, the null value. Instead of it going to null, we want to rewrite it to point to our list2. So list1.next is now going to be equal to list2.front. And all of this should only happen if we don't go in this if statement right here. So let's take this all out and put it in an else statement. Else, we're going to have this, let me indent it just for proper formatting. So if else. And then when we're done, no matter what, we're going to clear our second list because either it's going to be added in here or it's going to be added through here. So we can do list2 is dot front, and that's just going to get our front value and the entire list really, but it's going to set it equal to null. That'll set our entire, well, the front value equal to null, get rid of the rest of the list, and then we can close our method here. Let's submit this, and that will pass 7 out of 7 tests. That's how we would code for this problem. And that's going to be it for exercise 16.13 transfer form.